Hello everyone, and welcome back to Technically Unsure, where I'm not really sure what I'm doing technically, but it never stopped me before. So here we are. I know usually in this channel, I review mini computers, SBCs, building servers, benchmarking, things of that sort. I've done some cybersecurity videos as well. I showed you guys how to reverse engineer a UEFI and how to reverse engineer Android, and seems like at least some of you guys also enjoy that. So in this video, I'm going to try to make it enjoyable because it involves a game and educational. Even if you are an Android reverse engineering expert, I'm sure there's going to be some very interesting things for you to learn because I uncovered something that I don't think it's known or seen before or handled before. So sit tight, grab your favorite beverage. Let's do this. So how it all started, I will show you. Basically, it all started with this game, which is the BlockBlast. Seems like 500 million people are playing it just on Android ecosystem, and there's also the iOS and all that stuff. It's pretty simple. You see, this is exactly where you lose when basically there is no spot to put the items that is in here. Basically, that's when you lose, right? And if you make it to fill vertically or horizontally, it blasts like that. Okay, so this is the game. I just wanted to basically cheat. When you lose, there is a revive, but it shows you an ad. We're gonna talk about it. So I just want to start to give you the background. That's the game, and I wanted to see how it works. How can I cheat? How can I make changes? You know, stuff like that. And remember, this is an offline game, so even if I'm cheating, I'm joking, it's just for myself. You're not competing against anyone. So that being said, let's take a look at my computer right over here. As you can see here, I downloaded this APK bundle, APK-M, from APK Mirror. You can do this, or you can just download the app from Play Store to your phone and then use ADB commands to pull it out. But I just went the lazy way. I downloaded from APK Mirror, just an example. One thing you can do is literally, as you can see in the hex editor, it's PK header, so you know that APK files are APK bundles, and APK files are always a zip file, right? So if I extract this, you will see that I have a base and splits. So this base APK is the base, as it says, and the others are the differences in language or architecture. As you can see, these are for different languages, so most likely contains the different language string files and the language files. And these two, as you can see, are for ARM64 v8 or ARM v7, so it's different architecture, probably contains a native library for different architectures. These are all giveaways. And one of the things is, first we have to take a look at the base APK, right? So what we do is, I actually want to open a command prompt here, APK tool, decrypt, and base. So decompress. So here it will decompress and decrypt and extract all the text files, a manifest file, resources, all that stuff, and will give you a package that you can take a look at it just with regular file editors, right? So if we go to the base, you will see. Also remember, I did this in the previous video as well. One of the first things you always have to look at when you're looking at an Android file is the manifest file. It will tell you a lot about the app's capabilities. So here you will see the app permissions. You know, these are the things that it is using. Nothing important. We're not doing an application reverse engineering grid like that. Like, it's not a malware I'm looking at. I just know what it does, but I'm looking what it is using and how it is built and what I can do to reverse engineer and make changes. Okay, so one of the things I noticed right away is Cocos2D. That is a big giveaway, and I also saw the native library. I was expecting something like that. So if we Google Cocos2D, you will see that this is a game engine. Basically, people are using it to develop applications for iOS, Android, and even Windows, Mac, and Linux, as it says there. So it's a framework. It also contains native libraries and so on. Once you see that, it doesn't mean the Java side cannot have anything important, but usually you don't have a lot of critical things in the Android side, in the Java code, in Smalley, right? So you have to take a look at the native libraries and the Cocos related files, which Cocos also uses different JavaScript files. So Cocos is kind of reverse engineered before, and like there are articles and people have written codes and stuff like that for it. But here's the deal. We have to go back and you will see that there is a v8 Android split, right? So we extract that, and if we go, you will see that there's only these, doesn't matter. Important thing here is the only library, which is lib. And if we go in, you will see this is the architecture. If we go in, there you go. So these are the native libraries that the application is using. The most important one here is the lib Cocos2D. So that's the main core of this application, the main library that will decrypt and load and execute the JavaScript file. files. You may say JavaScript and encryption, what are you talking about? Good point, let me show you. So I am going to load this in ghidra because this is 26 megabyte file. This is going to take forever. So while that is loading, I just want to show you one thing, okay? If we go back here in this folder, you will see in the base one, if you go to, for instance, to assets, and if we look at the assets, so there is light assets and the main. Look at the main one, you will see that there is an index.jsc file. It's JavaScript but encrypted. So if we open this up in a hex editor, you will see that this is encrypted. It's not really a JavaScript code, right? And there are other ones as well. Like for instance, if we go here, here you see there's another index.jsc. And there are some JSC files that belong to Cocos2D, like settings.jsc and ESP stuff. But that doesn't matter to what we are trying to do, which is reverse engineer the game logic and maybe do changes that will be favoring us in the game. That being said, let me load the application in the ghidra and then we take it from there. All right, so I loaded the libcocos2d.js in ghidra. Okay, we are going to take a look at it. But before that, I want to show you. Let's go back here. As I said, there are some files like settings.jsc, and as you can see, and cocos2d.jsp, these are also encrypted. And if we open it in hex editor, you will see that these are encrypted, and we don't know the key, we don't know how to decrypt it, we don't know anything about it. So one of the first things you do is you just search Cocos2D, JSC, Decrypt, Android, right? GitHub. Let's see if anyone did anything for it. And you can see the first tool that comes up is this, an application in GitHub, a project, right? So you can basically run it, JSC Decrypt tool, but you have to provide an encryption key. And seems like that the Cocos2D is using XXTEA as the encryption, right? It's like fixed XXTEA, and it's the fixed version of TEA. What we can do is basically clone this repo, okay? Open up the bash and install the requirements. So let it install the requirements. Okay, see here XXTEA.py. And now if I do Python JSC decrypt, there you go. So it is asking for the file name and encryption key. Now the encryption key. So if we take a look at it, if you Google JSC Cocos2D decrypt encryption key, something like that, there are various articles, right? So just an example, it says just search in the Cocos library, search for game or .jsp adapter. So in this iteration, in this version of Cocos, apparently this worked, but it doesn't work anymore, not on the recent versions. So let me show you what I'm talking about. So if we go here and go to a hex editor and search for what they are saying here, right? If we search for this, okay. Okay, that's not dot, that's 00, okay? So you will see we are in a similar location as this. You will see the similar strings like game and then 00 and then JSP adapter. So JSP adapter is here. If we search again, JSP adapter, there's no more JSP adapter, that's it. So I'm telling you, I searched, it's not there. You know, there are different ways they are explaining in different articles how to find the key, but here I will show you two ways that is going to be, at least so far from examples that I examined in Android and Cocos2D, bulletproof. Okay, so we're gonna check. As you can see here, this is the format of the Cocos2D keys. So it's usually here is 8 character and then dash and then 4 character and then dash and then 2 characters. This is one way to do it. It's not the best way, but you know, if it works, right? So here is the deal. I am going to run the RegSearch. So I brought this RegSearch.py, and as you can see in here, it expects a file name and a regex, and it will search the file for that regex. So what I can do is I can say libcocos2d and my regex, which is basically alphanumeric 8 times dash alphanumeric 4 times dash alphanumeric 2 times. And if we run it, you will see that you are going to get 2 keys. One is the false key, the second one is the real key. So this is one way to do it. So I'm going to open a notepad++ so we keep track of things that we are doing. So far, we found 2 keys. That's one way of finding key. This is my regex code, okay? Now, let me show you another kind of better, kind of bulletproof way. I don't know, maybe future versions Cocos2D makes changes, but for now, watch what you can do. So you see here in the sections, you have to go to data.rel.ro, read only, okay? If we go here, you gotta skip through these initial stuff, and you can see function table starts, right? Just count to 3. 1, 2, 3. The third one, by the way, this is a stripped binary. So there are some GitHub library code that is going to try to basically use eval string and XXTEA app finished loading, some functions like that. None of that will work against this particular binary. It is stripped, and those I tried. None of the repos that are out there in GitHub will work against this game. You're not gonna get anywhere with those. I tried, trust me. So if you open this up, open up this function, you will see right here. You see, that's right exactly what we saw, this one. So it will tell you that this first one is probably not what we are looking for. This is the key that we are looking for. So we found XXTEA key. Now, in most games that using Cocos2D, you have the key and you have this JSC decrypt code. You should be set. That should be all. I will show you. It will work for some, not for the important ones in this game. They did something extra. Let me show you. So if I open this up, so here's the folder, okay? Let's go back, go to base. Look, if I go to assets, source, Cocos2D, or settings, easier one, okay? I'm gonna copy both. I'm gonna put them here. Look what happens. If I do this and then say settings.jsc and pass the key, right? Pass the key. Oh, sorry, I forgot the -t. Settings.js. There you go. We decrypted one. Let's try the second one as well. So while we are at it, the second one is going to be Cocos2D.jsp. Decrypted that one as well. Now, let's take a look at both of them in Notepad++. Would you look at that? This decrypted. This one is also decrypted. So yay, success, right? Wrong. No. So these are not going to help you with anything. There is no game logic in this. There is no core functionality of app is in there. These are just helper libraries, settings, you know, stuff like that. Not gonna help you. Trust me, I checked. Now, what will help you is actually if we go to the main and get that 1.5 megabyte compressed JavaScript file. So if we open this up, now look what happens. Same thing. I'm just going to replace this index.js, and in here I'm going to say index.jsc, right? Look what it says, invalid encryption. It doesn't work. How come? Why? So we are going to explore that, and that's where the critical key comes that others, whatever the blog posts are, is not covering this. First of all, I will explain what this decryption tool is doing. It's just good to know, right? So what it does is basically it accepts a key from you, calls XXTEA decrypt, decrypts it, and then uses gzip to decompress it. So you will know that all the JSC files are gzip compressed. Also JS minified. So as you can see in this one, like this large one, as you can see, this is minified. It's not really easy to read. We'll talk about it, okay? So it doesn't work for this one. So what I noticed was if I open the one that doesn't work, index.jsc, if we open it in hex editor, you will see something peculiar. You see this? JYCrypt. That can't be random. There are so many things that can be random. You can generate JYCrypt as random. So I looked it up. If you Google it, JYCrypt like this, you will get nowhere. There's nothing that says JYCrypt. So JYCrypt is something that these guys made up. No one wrote any article about it, any blog post or any analysis, and there is no way or explanation on how to decrypt this. So let me show you what is new, that what I uncovered. So here's what you can do. Let's take a look at this function and see. So here's where the reverse engineering comes to play. You have to pay attention and see what happens actually in the app, so you will be able to understand and decrypt the JSC file that you can't decrypt. Okay, so you will see that this one, if you hover your mouse over it, right? So here, okay, you will see that 8D58, and this one is 5456. And if you look at your key, it's part of the key here, 65485, right? So it is the key. And as you can see that in right here, okay? So it is just the hexadecimal way, but this is the key. Now let's take a look at it, what the application is doing with that encryption key, right? So we can understand the logic behind it. So if you look at it, it sets these variables into this and then calls this function. Let's take a look at it. And as you can see, it's basically just moving, copying that string into this variable. So if we go there, this is kind of like global variable, let's just say, okay? So what we can do is you can basically look at the code and everything else that is referencing this global variable. So what we can do is we can rename it and say XXTEA key storage. Okay, so the app is writing the key to this. Now I want to see who is using the key later. So if I go to the references and search for references to this, let's take a look at some of them. So one is obviously this same function, same code that's writing to it. The second one in here, oh, look at this. So this one is doing some stuff. XXTEA key storage. It's accessing the key storage here. And as you can see here, can't decrypt code. So here is where it is actually using the key to decrypt. Let's see how that happens. So the key is right here set into this variable, and then some stuff happens, moves the data from the key storage into this variable and then to this, and then the key is getting passed to this function. So if we go to this function, oh, look at that. So it allocates memory, sets, and calls this function, which is called twice. Okay, so it's the same thing, but if and else, whatever. So if we go into this function, look at that. This looks like a lot of operations being done on a string and looks like an encryption algorithm. You want to confirm that. You see some constants, right? These are constants and statics. Always what you have to do is just Google them. That doesn't look random. Oh, look at that. As soon as I Googled, look how many XXTEA articles came up and pages came up. So that static, that constant value is part of XXTEA. So that means this function is XXTEA. That means we have to rename this function to XXTEA decrypt. Okay, now let's go back. So this function was getting called. So this function is color to XXTEA decrypt. So we renamed this XXTEA decrypt color. So now let's go back again. So here it is calling XXTEA to decrypt it. But let's see the surrounding code. Is there anything peculiar, anything special, anything different? Oh, would you look at that? What does this mean? Let's take a look at it. Oh, read it from the right to the left. JYCRPT over here, PY, and the T is over here. And if you look at it, this one didn't work out, but this is JYCrypt, the same JYCrypt that's right here. Okay, so this looks like it calls this, checks for this JYCrypt, does some other function stuff before accessing the XXTEA storage and decrypting. Huh, interesting, isn't it? So let's take a look at it. So this first function does nothing. The second function does nothing. I mean, you understand what I mean by nothing. Then third one, look at that. This is XORing and XORing and XORing and XORing. And look at the time. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is just XORing stuff. It is doing first initial checks. So here, it's a long function, but I will tell you, there are static values. Look, if you go back here, so some variable number 7, some variable number 7, and the some other variables, right? So it is, the first one is the signature size, and then it is basically looking for that amount of bytes in the beginning, in the header of the binary file, which is JY decrypt. And then after doing those checks, it is basically a loop over here, do while, and it is just doing an XOR. That's it. So it expects a string and then it does XOR with that string, the whole file. And now the key is going to be the very same thing, JY decrypt. So here is the file that I wrote. Well, also I'm going to be very honest with you guys. I used a lot of ChatGPT to prepare this. So here is my code. I put the key, the XOR key in the beginning, which is JYCrypt. And then I put the XXTEA key, which is the same key that we found in the binary. So what it does is it accepts an input file, okay, reads the file as binary, then does an XOR on the whole file. So if you XOR the first 7 bytes, so if you XOR JYCrypt encrypt with JYcrypt, what are you going to get? 0000000. So we are going to remove the first 7 bytes, which are all 0. Remove the header, XOR it with itself, which is going to be 0. Remove it. Now we are remaining with the code that is encrypted with the next step, which was XXTEA. And then I call XXTEA to decrypt it, and then I call gzip to decompress it, and then I call the JS beautifier to just beautify that file, and here is the beautifier call, and then I write the output to the file. Magic. All right, so I showed you the Python code, right? So you can use this Python code as is, or what you can do is you can do this step by step. You can do the XOR and remove the JCrypt and then pass it to the original JSC decrypt tool, and you will see that it will work. But I already wrote the code, right? So the code not only decrypts, it does the XOR, decrypt with XXTEA, uncompress with gzip, also does JS beautifying, and then it just shows you the final code. Let's take a look at it. Let's see if it works. So if I say Python Decrypt.py and index.jsc, let's see what happens. There you go. So it took a while because of the JS beautifier code, okay? So if we go to index.js, you will see it's a 15 megabyte of file. If we open it in Notepad+, ta-da! There you go, okay? You will see this, but it took me a while to get to this point, which I will share all my code with you all. I will put the links in the description so you can use it. But my point was how you can reverse engineer is something that you don't know anything about it, how it works, using basic tools, ghidra, and reading the pseudocode and understanding and putting 2 and 2 together. We barely use the APK tool here. So this is the code. I don't know the YouTube rules, and every time I see some legal documents, I just start yawning and I go to sleep, right? So I don't know the rules of YouTube. I don't want to show you guys how to actually break the game and do something that is going to be cheating of sorts, but I will give you some small pointers, right? So if you basically search for revive, if you go to revive, there is going to be where it gets the score and looks for the reviving code, right? Here, add revive, update score. So if you look at the add revive count, which always gets called every time you score, you add a score, you put an event object to the screen, it is changing the score, right? So what you can do is you will see there are some switch cases, and sometimes it returns 2, which is kind of, I think, like the maximum revive count per game. So what you can do is you can always make it return 3, return 2, something like that. Just a pointer. And where it is subtracting the revive count, deducting from it, which is right here, you can maybe just say, yeah, you know what, don't deduct it, you know? So it's always at the max level. I'm just giving you a couple of pointers, right? Here's the most sophisticated part, actually. It is actually now, let's say you made some changes, you remove this, and you look at the code and all that stuff, and now you want to basically save this, and you see what I'm going to do? You have to reverse the whole process and go backward. So to go backward, what you have to do, step 1, minify this JavaScript. Step 2, compress it with gzip. Step 3, encrypt it with XXTEA with that encryption key. Step 4, XOR the whole thing with JYcrypt. Step 6, write JYcrypt string as a header to the file, and then write the result output. So in order to do that, that's a lot of work, right? So let me show you what I did. I brought my encrypt file over here. Now let's take a look at the encrypt file. So encrypt file does exactly what I just said. Same thing, same XOR key, same XXTEA key, encrypt file, input file, right? So what it does is it reads the binary file. This one is actually not necessarily binary, it's a JavaScript code. This is the index.js. So what it does is initially it uses JSmin to minify the JavaScript code. Then it uses gzip to compress the minified data. Then it uses XXTEA to compress the data, to encrypt the compressed data. Then it uses the XOR key, which is JYCrypt, to XOR the bytes. Then it writes the JYCrypt to the file and then the resulting bytes to the file. And that's going to be whole reverse operation from where we came here, right? So let me also show you that part. I want to use a different name because it will override it. So I will just say modified.js. Let's say you made your changes and all that stuff, right? So you come back over here and you say Python encrypt now and say modified.js. Now let's see what happens. Again, minification will take time. Okay, there you go. Modified.js, and would you look at that? Isn't that beautiful? So now if you look at it in the hex editor, you will see JYCrypt and everything else is exactly like that. Now you want to double confirm that you did everything right. So what you do, you rename this as a test. Now we want to test. Remember the original code that decrypted and gave us the JavaScript and everything? You just want to make sure that it is actually still working. So what you do is Python Decrypt.py and test.jsc. So this is going to take time again because of the JS beautifier on a 15 megabyte file JavaScript. So if it works, you will know that you created exactly the same file as original index.jsc. So all you have to do is confirm and then confirm file, the final file. Make sure there is no JavaScript errors because otherwise the game crashes, doesn't work, right? There you go, test.js. So if we open this up in the editor, there you go, you have the code. So what you have to do is take this test.jsc, encrypted, compressed, encrypted, all that stuff, test.jsc, copy that, go back to assets and main, put that in here, delete the JSC and put yours in place, and then basically compress and sign your APK and put it back in the module and then install it on your phone. So this hacking part, maybe that part is against some sort of rules. I'm not gonna do that part, but I wanted to show you how enjoying reverse engineering and Android application can be, okay? Hope you guys learned something. Hope you guys enjoyed it. I definitely enjoyed doing this. It was a challenge. There is no article or anything that can explain this method on the latest Cocos or the Cocos that are modified or these guys did something. Doesn't matter. I just wanted to explore the unexplored and figure out the solution on my own and share it with you guys. So one final message. Any of you watching this are very good at reverse engineering Android applications and you know encryption, Java code, Android ecosystem, you know broadcast receivers and you know services, you know how to decrypt the smally code, decompile the smally code, analyze it. You can do what I just showed you guys in the video more or less. If you are in US, get in touch with me. I know a place where they are actively hiring experts in Android reverse engineering. Okay, my channel name is Technically Unsure, but the email is unsure-technically, so at Gmail. Contact me with your resume if you're in US and if you can do what I just did more or less. Again, you don't have to be really super expert, but if you are familiar with the concepts of reverse engineering and Java decompilation and Java code and Android ecosystem and all that stuff, get in touch. Okay, thanks for watching. Hope you guys enjoyed it. If you guys like this type of video, let me know. I can do similar videos more and often. Yeah, you guys decide what I put in the channel. I see what you guys like. I put the same similar contents on my channel, so it's up to you. Thanks for watching and I will see you in the next video. Bye for now.